Good. So let's jump back to the technical content. So we have used the word this, the reserved word this multiple times before, right? And we know that it refers to the constructor that we are in right now, right? So just a last thing about this is you can invoke. So assume, you remember we said you can have constructor overloading. What do you mean by method overloading first? What does it mean to have a method overloaded? Yeah. Exactly. And then because constructor is a method, then you can have you can have constructor overloading, which means you have multiple constructors for the same class. Each one of them takes a different number of input parameters, right? Then assume you are right now in one, and I gave you this example before. Assume you have instance variables, like I don't know, like 100 instance variables for a class, right? And then you write multiple constructors to initialize sets of that. Maybe one constructor initializes like 5 of them, another constructor initializes 10, etc., etc. You don't need to re-implement everything for the bigger constructor from the beginning. You can actually call another constructor of the same class within the constructor you are in right now. And the way to do this is to just use this, which is the reserved word to refer to the class you are in right now, and then pass the corresponding number of parameters that you want to pass. To give you one example, assume you have this constructor here, which takes A and B for the point class, which is like X and Y, right? And then you initialize them. You can also define a constructor that takes only one input value and internally initialize both X and Y to the same value, right? You can have this and this. One thing you can do is, instead of implementing inside this thing to say set A, which, because what does this do is actually making X equal A and Y equal A. This can be written in another way to say public void int A and then set AA, similar to this, right? But we wrote this in this way to tell you that what we just do here is to call this constructor and pass A as the two input parameters to this constructor, which means you are in one constructor right now, you call another constructor by using the word this. Right? Here, it may not make a big difference because both are just like a single line of code, but this can save you hundreds of lines of code. Where? Oh, there should be here, yeah, it should be like this. Thank you. Just a typo. Okay. Should be something like this. Yeah. Okay, thank you. But this is the main idea, is you can call a constructor from another constructor, even something. And then for methods, not constructors, you don't need the word this. Assume you have multiple methods. We also know we have method overloading, right? You can have multiple methods with the same name, different input parameters, similar to what your colleague said. And you can also call one of these methods inside the other, right? But you don't need the word this because all are member methods and then they can call each other. The thing here that we needed this for is a constructor. Effectively, you cannot call a constructor, right? There is no way to call a constructor other than defining an object, right? But this is a way to call another constructor if you are already in the class, right? This is why it's a kind of a special thing. Good? Okay. So reference variables. What do you mean by reference variables? Reference variables, objects, instances of a class all refer to the same thing, which means you define a variable of class type, right? I guess we mentioned this before, but now we we cover it in more detail. What kind of operations we are allowed to do on class objects, right? Previously, we took one operation which is assigning an object to another object. Remember this? For example, you define point B1, B2. We did this example before. And then after initializing B1, for example, you say point B1 equal new point. So you create this object in memory. Later, you can say B2 equal B1. Can someone remind me what happens when I say this? If I assign B2 equal B1 in our point class? Yeah, it points to the same place in memory. You don't create a new place in memory. You don't create a new object. Rather, you make both objects refer to the same place in memory. B1 and B2 are referring to the same thing, right? And we had multiple examples about this. Another operations we can do is to check equality. You can check whether an object equal to another object or not. What does it mean? What kind of equality it checks? It checks whether both are referring to the same thing or not. And this is different, and it's not a value equality checking. You can think of this as a value equality checking, but for the addressees rather than the values themselves. So if you have an object in memory, the example that we gave, B1 and B2, both are referring to the same thing. In this case, B1 really equals B2, right? So this is the equality checking we are doing right now. Not equal is the opposite side. Both are referring to different places in memory. Typecast, we will discuss this in more detail when we come to inheritance, but you know what is casting from C and from Java. What is typecasting? Yeah? And when it's allowed. When can I do a cast? Yeah? You are moving from a narrow type to a wider type, but in this case, you don't need to explicitly do a cast because the compiler will do this for you. What is the other case? You are moving from a wider to a narrower type, but it's an allowed cast, like moving from double to int. You can do this casting, but then now you have to explicitly say you want to cast from double to int, right? So the same thing for classes, and the mindset here is classes are also data types, right? Then you can cast from another class to another one if it's allowed. We will see now what we mean by this, right? This is mainly about class inheritance. And then we all know the dot operator, which is referring to the members of this class. Something that is, I guess you guys should know by default, is you cannot use the dot operator for another reference, right? This makes sense. You didn't create an object yet, so it's not referring to anything, and it doesn't have members. So you cannot say point B1. Now you are declaring B1, but you didn't create it yet in memory using the reserved word new. You cannot say B1.x or B1.getX. This is not allowed, right? Because you didn't create this object yet. Another thing that is allowed on object is to say it's an instance of. Why this is needed? This is usually used when you want to check whether an object is of a certain type of class. For example, we define B1, B2 as objects of point. Later in code, maybe you need to do some checking whether B1 or B2 are really objects of point, and then you can use the instance of method or operator to say that B1 is an instance of point, right? And then we cannot do arithmetic operations, inequalities, anything that is related to normal value mathematics. This is not allowed for classes. Here are some examples. We define two new objects, B1 and B2, and then we define a third one. We have went through this example before. Then we said point B3 equal B1. Now B1 and B3 are pointing to the same place in memory, right? Now if I check the equality, and this is a new thing here, if I check the equality whether B1 is equal to B3, this is true, because both are referring, equality here means both are referring to the same place in memory, right? So B1 and B3 are equal, because both are referring to the same object. But if you check B1 equal B2, B1 is a place in memory, B2 is another place, right? So these are pointing to two different objects. Yes, of the same class, but they are different. The trick here, maybe you can think of, they have exactly the same values, right? And this is the thing, we are not checking value equality here. Even if they have, every member of them have the same value as the other member, it doesn't matter. Equality for objects means both are referring to the same place in memory. It doesn't mean that they have the same value for each member, right? Is there any question? Good. And like B1 does not equal B2. So to understand this better, you can also think of this as the name of the object. You remember from pointer mentality, the name of the object is an address to a certain location in memory that holds all the members, right? So just similar to the array name in C, similar to pointer in C, and here the name of the object itself. So it's an address in memory. And what we're checking here, whether both addresses are the same or not, right? So in case of B1 and B3, both are the same because both refer to the same place in memory, so they have the same address value. Sorry, so you want to change this assignment thing? So you would say point B2 equal B1. Here, point B2 equal B1. Yeah, you can do this. But now you lost this place in memory because you redefined, you relocated B2. So here's what happens. For the first line here, you created a place in memory, one object, and made B1 point to it, right? And then in the second line, which is defining B2, you created another place and made B2 point to it, right? It's a valid statement afterwards to say B2 equal B1, but now you are moving this pointer to the other object, so you lost access to this. That's fine, but your question was whether now if you check the equality of B1 and B2, whether they are equal or not, they will be equal, because they will have the same address. Yeah. You cannot even access this. There is no point. I mean, if you are referring to the other thing that you define, which is the second line here, you don't have access to it. Now you lost access to it. B2 is not anymore referring to this object. The important message here is you have to differentiate between the actual data content in memory and the name of the object that is referring to it, right? By just moving the name of the object, which is B2 in this case, to B1, you lost access to this data, right? Yeah. Yeah, it's already there in memory because you already defined it, but you don't have the address of it, right? Yes. Okay. You can define a class as, so previously we discussed the access modifiers of members of a class. We said we started by defining variables as public, and then we said now you can access them from anywhere. And then we said one of the purposes of object-oriented programming is to make it protected, to make it secure. You don't provide public access to everyone, and then we define them as private, and then we introduce the setters and getters, right? Now, what about the class itself? You can define the class as public, which is the traditional thing, because you want to interact with this class. Make sure you can create objects out of it, then it can be accessed by anyone. If you didn't define a modifier of a class, what does it mean? You didn't put any reserved word in front of the class definition. You didn't say public, private, anything. Then by default, it's accessed only inside its package. And we'll see what does it mean to have a package right now, right? In your terminology for now, you just can assume this is like the same folder of your project. Good? And then we have covered public before, so you can access those members from anywhere. We didn't cover protected yet, so I'll come into it. Then if it's no modifier, so it can be accessed only inside the package, again similar to the class. Then you can have private. Then we know from previous lectures is private, you cannot access these variables directly, you have to access them through setters and getters, right? So these are the protected variables inside the class. So what does protected mean? Like we have public and we have private. Where protected lie in this scale, right? So we will come into this because this is very important for inheritance, which is, I hope we have time to cover this in this lecture. So just keep protected for now, right? But we said packages. We said something about packages. So what is a package, right? If you already started doing Lab 4 and using NetBeans or any other infrastructure, then you know everything in Java, and this is a very good thing about Java, other than C. Everything is organized as folders and subfolders and subfolders, right? So once you define a project, it creates a package for you by default. A package means just a folder, right? And then inside this package, you can have multiple classes, which means they belong to the same package. Good? Previously, we had examples to access certain class from the Java library. We said java.system.something.something, right? Something like that. What are these dots? You are moving across packages, right? So say, I want to access this project, this folder inside this project, this subfolder inside this folder, etc., 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 right? So a package is a directory structure that organizes all your classes in the project. So it's the same mentality of object-oriented programming. Why I would like to use packages? Because first of all, it's a good organization. Now everything is organized in folders and subfolders. So if your project assume for example you are 10 people working on the same project, you can define, every one can define his own package, and then you can combine this at the end into one complete library, right? And then also to avoid name conflicts. What does it mean? In the same project, you cannot have two classes with the same name, right? Makes sense. If you define a class point, and then you define another class that is called point as well, there must be something wrong, because which one to access if you are going to instantiate an object out of point? So this is not allowed. So each class has its own name. But what if you want to do such thing? What if you want to have two classes with the same name for a certain purpose, right? In your big project. Then by defining packages, this is allowed, because a package is like a barrier, right? So I can have two packages, which means two folders. Every one of them has a class that is called point. And this is allowed. Why? Because the first class, assume this is subfolder, I don't know, like package 1 and package 2. The first point class, its name is not point anymore. Its name is package1.point. And the other class is package2.point. So the package name or directory name now is part of, in the infrastructure of the compiler, it's part of the class name. Right? That's why you can have multiple classes with the same name. And then finally, to provide protection, because we said, for example, if you define a class with no access modifier, then you can access it only within your own package. Going back to the example we gave, if you have 10 people working on the same project, assume you are doing something internally, but you don't want the other team members to access it directly, to access it only through your interface. The same mentality of object-oriented programming. Then, if you don't give an access modifier to the class, only you in your package can access it. Other packages on the project cannot access this class, right? So you can also define multiple levels of security or protection with. Is there any question? A lot of theory information here. So let's see one example, right? So assume we define a package that we call mcmaster.ece.graphic. How do I define such a package? You either say this before the class name in your folder. So you would say package mcmaster.ece.graphic, and in this case, the compiler, when you run this code, will create the package for you. Or you don't need to write this line, and you create the folders yourself. So you create a folder that you call mcmaster, and then an inner folder that you call ECE, and then another inner folder that you call graphic, and then you put your class inside the graphic folder. So you either do it yourself manually, create the structure of the directories, or just in Java write package this thing, which means you are declaring a package right now. And then when you run it, the compiler will create the subdirectory infrastructure for you. Good? So all of this we have already mentioned. Another thing that is important here is, by default, if you don't define a package, then the folder that you are in right now, the current directory is the package of the current folder. So we mentioned, for example, if you don't have a specifier in front of the class definition, it means this class can only be accessed by classes on the same package. What if I didn't define a package? It means it can only be accessed by classes of the same folder, right? And this is something that is important in your lab if you need to come across this thing. And then by doing this, this point class has to be saved in this subdirectory. Okay. So now the full name of the class, and this is why it can be, or it's allowed to have multiple classes of the same name if they belong to a different package. Because again, now the point class is not called point anymore. For the compiler, it's called mcmaster.ece.graphic.point. Right? So it has the full directory name of the class name, which means in another folder you can say mcmaster.ece.2sh4, but don't start with a number. I don't like programming.point. You can have a class in another package with the same name. Okay. You can only access a class outside the package if it's public. Import, if you want to import something from another package, you can access. So what does it mean? So assume I define two packages in my project. Good. One has a class point, another one has the class circle. Remember, we defined two classes, circle and point. You cannot directly instantiate objects of class point inside circle because it belongs to another package. You either need to specify the full path in your code, which is very bad, not a good programming skill, and it takes a lot of time to write. But you can also, similar to include in C, you can import packages in Java. So you can import, if your point class is in mcmaster.ece.graphic.point and you want to use it in another package, at the beginning of your code, you just write import, and then you import mcmaster.ece.graphic. By doing this, you are importing the full package, including all the classes in this. By doing this, now you can create objects of point, and the compiler will know that you are referring to the point in the package of mcmaster.ece.graphic. Right? Something like this here, import mcmaster.ece.graphic. If you just say .point, then it only imports this class. If you import the package as a whole, which means everything, then it imports all the classes within this package. Right? Okay, so this shows you within the GUI what would it look like if you have the subdirectory of subdirectories. Something like in Lab 5, for example, if you have a Lab 5 project inside a certain folder, this folder is your package. Okay? Is there any question?